Hello, welcome. Today we'll see the rules to assign the oxidation number, and this is very important in the balancing chemical reactions. First of all, we'll see the rules for the free atoms of an elements. Free atoms, that means which are not in combined form, and oxidation number of such atoms of an element is 0. So example is like hydrogen, oxygen, chlorine, nitrogen, then ozone, sulphur, phosphorus, copper, silver, calcium, magnesium, etc. All these atoms of an element in a free form has a 0 oxidation number. Oxidation number is 0 for these elements. Now second rule for the hydrogen atoms, will write hydrogen atom. Oxidation number of the hydrogen in metal hydride and in simple different compounds and in compound form. In the compound form like HOH, the oxidation number of the hydrogens here +1, here is +1, this oxygen has -2 oxidation number. Whereas in different metal, non-metal, and the hydrogen is +1 and this is -1. That means with non-metal, hydrogen has a +1 oxidation number, and with metal, examples sodium hydride, calcium hydride, in which this metal always lose electrons to non-metal. So the hydrogen is a non-metal and both this electron withdraw towards the hydrogen, that's why the hydrogen carry -1. Here also this both electron withdraw towards hydrogen because it has more electronegativity compared to this metal, that's why both electron comes to the hydrogen, that's why this carry -1. And if these two electron lost to this hydrogen, that means these metals carry +2 charge. This calcium is an alkaline earth metals, so it always carry +2 charge. Sodium is alkali metals, it carry +1 charge. This is a -1 because this sodium lose 1 electrons to hydrogen, that's why hydrogen carry -1 charge. Hydrogen already having 1 electrons, and if 1 electron is added from the another atoms, for example these metals, then 1 electron is added to the hydrogen, that's why the hydrogen carry -1. That's why in metal hydride, hydrogen carry -1 charge, and with non-metals, the hydrogen has a +1 oxidation number. Now in this case we have seen the alkaline and alkali earth metals. So this third rule we'll see. Rule number 3 for alkali metal. Alkali metals, example lithium, sodium, potassium, rubidium, cesium, francium. All these elements having 1 electron in its valence shell, and after loss of the 1 electrons they carry +1 charge. So this is the oxidation number of alkali metals. Next, oxidation number of alkaline earth metal. Alkaline earth metals like beryllium, magnesium, calcium, strontium, barium, radium. These are the alkaline earth metals, and these all having 2 electrons in its valence shell. After loss of the 2 electrons they carry +2 charge. So it is the oxidation number of these alkaline earth metals. Next, oxidation number of iron. That is next rule. Oxidation number of monoatomic ion. Monoatomic ion. Example Cu 2 plus is a monoatomic ion, only one atom. Mn plus 5 or Fe plus 3 or Fe 2 plus. These are the monoatomic ions, and the oxidation number of these monoatomic ions is equals to charge on it. So charge on it is here plus 2 is the oxidation number, here plus 5 is the oxidation number, here plus 3 is the oxidation number, here plus 2 is the oxidation number. Next rule, the oxidation number of the oxygen. Oxidation number of oxygen. Oxygen in the compound form, different compound form like HOH. Here hydrogen, earlier we have seen this has a plus 1 when it combined with non-metals. It is plus 1 charge. This is also plus 1 charge. Then to balance this plus 1, that is plus 2, this oxygen carry minus 2. So this oxygen carry minus 2 is the oxidation number in the compound form. So in the different compounds, another that is the magnesium oxide, in which just now we have seen the magnesium is alkaline earth metals, it carry plus 2 charge and the oxygen carry minus 2. That means in this compound it also carry minus 2, which is the oxidation number of the oxygen. Then in peroxide like HOOH is a peroxide. See, this hydrogen is a plus 1, this hydrogen is a plus 1, and this oxygen carry here minus 1, minus 1. That means in this peroxide the oxygen has a minus 1 oxidation number. Then in superoxide like KO2 is a superoxide, maximum oxygen is combined with the metal. This potassium is a plus 1 charge, and to balance this plus 1, this O2 must carry minus 1. So on one oxygen there is a minus half charge. So in superoxide the oxygen has a minus half oxidation state. Another example, OF2. The fluorine has always minus 1 oxidation number, and there is a 2 fluorine. So 2 fluorine, that means total charge is minus 2. To balance this minus 2 charge, the oxygen must carry plus 2 charge. That means in the OF2 the oxygen has a plus 2 oxidation state. This oxygen has a different oxidation state in different compounds. Now sulfur. Sulfur in the sulfide, in its sulfide form, that means H2S, the sulfur has minus 2 charge. Here one hydrogen has a plus 1 charge, so 2 hydrogen, that means plus 2 charge, and to balance this, the sulfur has a minus 2 charge in the sulfide form. Now the different metals. Metal always has a plus charge, plus oxidation number, but in some cases the metal has a minus oxidation state. Example, some metal hydride like Cu, HCu, in which this copper carry minus 1 charge. This is a metal hydride. It's a metal hydride. Whereas in some metal carbonyl compounds, example of this is cobalt, CO bracket 4 minus, in which this cobalt is CO is a carbonyl group which is a neutral, there is no charge on it. That means the charge on this complex is nothing but this charge on the cobalt. That means here this cobalt has a minus 1 oxidation state. Another example, suppose rhodium, the carbonyl groups minus 1. That means this charge comes on this rhodium, it has a minus 1 oxidation number, because this carbonyl group has a 0 oxidation state. There is no charge on this carbonyl group. That's why the charge on the complex is nothing but charge on this central metal. That's why the charge on this is minus 1. Whereas in all different compounds the metal has always positive oxidation state. Next, halide. Halides, here fluorine, chlorine, bromine, iodine. Fluorine has always -1 oxidation state, always in the different compounds. Whereas the chlorine, bromine, iodine, it also shows -1 in different halides. Example, HCl, HBr, HI, in which all these shows -1, -1, -1, and this hydrogen shows +1. But when this chlorine, bromine, iodine is combined with the oxygen, then this shows +1 oxidation state. Example, suppose ClOCl or HOCl. This oxygen is more electronegative compared with chlorine. This carry -1 charge. But here the 2 chlorine is there. So this chlorine carry +1 charge. This chlorine carry +1 charge. So oxygen carry -2 charge. Here in this case, the oxygen is again -2 charge. This is a +1 and this is a +1. That means this chloride has a +1. This chloride is also having +1. Whereas in interhalogen, these carry different charges, different oxidation number. Example, ICl, in which more electronegative elements carry -1 charge and less electronegative carry +1 charge. Suppose IF3, this fluorine 3 times. So this carry -1 on 1 fluorine. There is 3 fluorine, so total charge is -3. To balance this iodine must carry +3 charge. This iodine has a +3 charge. Is IF5, the fluorine has -1 oxidation number, and this iodine, see, total charge on this fluorine is here 5 into -1, it is a -5. To balance this iodine must carry +5 charge. Or IF7, here the one fluorine carry -1 charge because fluorine has always -1 oxidation number due to its more electronegativity. And iodine, to balance this -7 charge, must carry +7. That means the chlorine, bromine, iodine, they carry different charges in interhalogen. In interhalogen they carry -1, +1, +3, +5 and +7 oxidation number. Now the next rule, that is, in the neutral compound we have to find out the oxidation number of some unknown elements. Example, suppose MnO2, in which we have to find out this oxidation number of the manganese. So there is one rule, and the rule is that the algebraic sum of all the atoms, algebraic sum of the oxidation number of all the atoms in neutral molecule has a 0 charge. Means oxidation number of this we have to find out, it is considered as X, and oxidation number of this, you know that -2 is the oxidation number of the one oxygen, and there is a total 2 oxygen, so this is a 2. So sum of this oxidation number is equals to charge on this, there is no charge, that means this is called neutral molecule, and the charge on neutral molecule is 0, so we will write here 0. So rule is that algebraic sum of oxidation number of all the atoms of an element in the molecule is equals to 0 in the neutral molecule. So X minus 4 is equals to 0 and X is equals to plus 4. So the charge on this Mn is plus 4. It is the oxidation number of the manganese. Another one more example we'll see. KMnO4. These are again neutral molecules. So rules state that the oxidation number of all these elements is equals to charge on it. Charge on this is 0 because it is a neutral molecule. So the potassium, their oxidation number is plus 1 because it is alkaline earth metals. Alkali metal, sorry. And this manganese, their oxidation number we have to find out. So it is considered as a X. Oxygen, their oxidation number is -2 and the total oxygen is 4. So sum of this, that means their addition of all this, that must be 0 because there is no charge on this compound. That's why this is 0. So here X plus this 1 plus here this is 4 into -2, that means -8 is equals to 0. So X minus 7 is equals to 0. So X is equals to plus 7 is the oxidation number of this manganese. So the rules state that the algebraic sum of the oxidation number of all the atoms of an element in a neutral molecule is equals to 0. Now if this polyatomic ion is present, then another rule state that next rule, the oxidation number of an atoms of elements in the polyatomic ion is equals to charge on it. Example, suppose MnO4 minus, this is a ion or it is also called radical, and the oxidation number of all these elements is equals to charge on this. Charge is here -1. So we'll find out the oxidation number of this manganese and it is considered as a X. Then plus means addition. Oxidation number of the oxygen is -2 into number of oxygen is 4 is equals to charge on this ion is -1. So X minus 8 is equals to -1. So X is equals to -1 plus 8, that means it is a plus 7. Plus 7 is the oxidation number of this manganese. Another example, suppose we'll write Cr2O7 2 minus. Now in this case this chromium is 2 times. So and we have to find out the oxidation number of these elements. So oxidation number of the chromium will consider as X, but the chromium is 2 times, so we have to multiply by 2 to this X plus oxidation number of the oxygen is -2 into 7 because the oxygen is here 7 times and is equals to charge on this ion is -2. So here 2x minus 14 is equals to -2. So 2x is equals to -2 plus 14 is equals to plus 12. That means x is equals to plus 6. So plus 6 is the charge on one chromium. This is the oxidation state of the chromium. Now one more rule, that is when 2 or more atoms of the same elements are present in a polyatomic molecules or ions, then oxidation number of the atoms of an element is the average oxidation state or average oxidation number of that atoms of elements in that molecules. We'll write examples. Suppose Na2S4O6 is the example in which the sulfur is 4 times. We'll write the structure of this. Sulfur is 4 times. Oxygen is here 6 times. So here oxygen is 6 times, and there is a sodium 2 times. Sodium, this carry plus charge, this negative, this negative. If you find out directly the oxidation number of the sulfur, then we have to write the average oxidation number of the sulfur, because this sulfur is 4 times. So we'll write according to this rule. This is the neutral molecules. The sodium 2 times, so the oxidation number of sodium is plus 1, and there is 2 times sodium, plus sulfur is 4 times. We have to find out oxidation number of sulfur, and that's why we have to consider X is the oxidation number of sulfur, is a 4 times sulfur, plus oxidation number of the oxygen is minus 2 into 6, and charge on this is equals to 0. So here x into 4, that is a 4x, plus 2 minus 12 is equals to 0. So 4x minus 10 is equals to 0. Therefore x is equals to, or we'll write 4x is equals to plus 10. Therefore x is equals to 10 by 4. That means this is a 5 by 2 is the oxidation number of the sulfur, and this is considered as the average oxidation number of the sulfur. In this way, these are the different rules. Another thing, the oxidation number, it may be 0, it may be positive, it may be negative, or it may be fraction. See, the maximum oxidation number of any atoms of an element except oxygen and fluorine is equals to their group number. Maximum oxidation number of any atoms of an element except oxygen and fluorine, इसके अलावा जो भी other elements है उसका maximum oxidation number मतलब उसका group number, and minimum oxidation number except this oxygen and fluorine is considered as the 8 minus group number minus 8. Group number minus 8 is the minimum oxidation number of that atoms of an element except this oxygen and fluorine. Okay, so these are the some rules to assign the oxidation number of the different atoms of an element in the molecules, and these are very useful during the balancing chemical reactions. Thank you.